3, and we're still on the transition to our book. So we'll start with combustion control, and we'll talk about the controls for oil burners. The idea of focusing on oil burners is because if you can master the controls for oil burners, probably you know all the controls for other ones, mainly commercials and also for gas. So this is the book. So we're going to start with the first chapter. I highly recommend that you read this book. It's very, very well written, and it's been used for years. And if you study this book, you qualify to go and take the NORA exam. And this is also the book recommended for technicians to study for the Massachusetts oil burner exam.
Oh, my brother just took that.
Yeah, how was it?
He said it was pretty hard. He's not doing anything like this,
Yeah.
but he got a 76 without really going too much.
That's good, yeah.
Yeah.
So you pass it,
Yeah.
70 is passing. So we'll talk about oils and its properties. So we have a diverse group of fossil fuel oil. So crude oil comes in as sometimes it's light, sometimes it's heavy, and it can be broken down into different kind of oil. What happens is the oil get distilled. It's a big distillation process. There's a different compartment for each oil to condensate that. So they boil the crude oil coming from the well into a big tower, distillation tower, and they collect every fuel at each point. So if we look at distillation tower, if you've been to a refinery, if you want to have some interest, so you pump in here crude oil, and we have different distillation process. So here you'll find oil number 6, number 5, based on the density.
So
Number
less crude as it goes up higher.
Yeah, it's going to be lighter.
Yeah.
3, number 2, then you have kerosene, and here you have naphtha. And as the crude oil comes in from the well,
What's that topic about?
naphtha. You don't have to know this, but it's good information. So let's imagine that this is the oil well here. As it comes out, there's a lot of gas.
So that's AC.
L,
Kerosene.
E, G. So what they do is they capture the gas through a vent and then liquefy it. LPG is liquefied. Petroleum gas. So they capture all this gas and take it to this here, into LPG. Of course, you have to cool it to make it liquid. And the rest of the oil will go as liquid into the distillation column. Of course, there's a lot of process, but this is to help you understand how does it work.
What's that above kerosene?
It's again, it's part of the distillation product. So this is number 6. It's the heaviest oil. It's heavy as honey, very viscous. They use that for asphalt. They use those for burning. You can burn it up, but you need to heat it to get it to be porous. So you can pour it and move it. So number 6, 4, 5, 3. Number 2 is what? That's what we use. It's diesel oil. Kerosene is used for jet fuel and can be broken down. It's a little bit thicker. Then you have a naphtha. That's gasoline. That's what you find in your Zippo lighter. That's naphtha. You add some stuff to it and it becomes gasoline. That's what gives it the octane level and becomes more flammable.
Butane.
Huh?
Makes it into butane?
No.
I always
That's
thought that was
gasoline,
a
no.
brand name.
Butane is gas. It comes from here. Petroleum gas can be butane, can be propane, can be any kind of gas. You can break it down into different
That's
parts.
what kind of, that butane is what goes into a lighter.
No,
No, not
Zippos
Zippo lighter.
use that.
No?
No.
Oh, no kidding.
Yeah. The butane goes into the gas lighter. That's gas. But for naphtha, the liquid is put in a Zippo lighter,
Ah,
or that's naphtha. basically it's kind of gasoline, which means you can also put gasoline in your cigarette lighter, but it smells really funny. So this is diversity of fossil fuel, and in some plants they also use coal. Charcoal is also fossil fuel. So fossil fuels all came from organic matter that has been stored in the ground for millions of years. Petroleum, the word came from Greek. Petra is rock, oil is oil, so it's the oil of the rocks, is what they used to use as a terminology, and that's how we got petroleum. Petra is always a Greek term for rocks. Oil is lighter than water, no matter what. Even number 6 is lighter than water. So if it seeps from the bottom of the ocean, it's going to float on the top. So always remember that. Oil is going to be lighter than water. So whenever you have oil, it's going to float up in the ocean. And if you have oil in your tank, the water will be at the bottom. How long will it last? That's always questionable. But from what we know so far, we have reached peak oil, which means the maximum amount you can get from oil. And now we're just getting less and less. However, new technologies are coming to get oils from the ground. That's been there, but eventually it will finish. So oil is stored in the crust of the earth. And from now we have reached peak oil for easy extraction oil. There's still some oil in the North Pole. There's some oil that's inaccessible, but there are new technologies to get it. But eventually it is going to go away because it's a limited amount of it. If it was an ocean, it would have been dry by now, or big sea, because we are pumping a lot of oil. We're consuming more than 20 million barrels of oil a day.
We wanna go through all solar, right, eventually?
Well, eventually you can get some renewable fuel, and this is the question about renewable oil products. So, oil, even though it has been stored in the earth and fermented over millions of years, you can get some fuel out of plant, out of regular oil. And we said that for diesel oil, you can substitute that by corn oil, or canola oil, or peanut oil. So we can still get some oil. However, it's not as cheap. It's a big process, big chemical process, so it's not going to be as cheap. And a gallon of peanut oil is around like $10.
You ever see one of them cars that go to the restaurant and get their old oil, it smells like a restaurant when you're driving down the street?
Yeah, there are some people who use frying oil to substitute for peanut oil. You have to filter it, and you have to change your combustion in the engine to have it work smoothly with regular plant oil. So fuel oil and sulfur, we gotta talk about that a little bit. So some say that sulfur for the dinosaurs was like the hemoglobin for the human. It was the substance that enabled their blood to carry oxygen. So oil always will come with sulfur. Even up to diesel, there's always some sulfur, and sulfur is very acidic, and it will eat your equipment, and it's also very polluted. And at some point in the 80s or 70s, they used to have what they call acid rain. By burning coal and burning fuel oil, you will get some sulfur gas to go into the atmosphere and condense with the water, and the rain become very acidic. That it will ruin your plants and also will strip the paint out of your car. So then they had the Clean Water, Clean Air Act, and they started to take sulfur out of the oils. So taking the sulfur out of the hydrocarbon is a very lengthy process, and it's very costly. So the more process you add to the oil, the more you will pay for it. So in the US here, we have low sulfur. That's why now the diesel does not smell as bad as it used to. And if you go to Europe, they have zero sulfur diesel. They extract all sulfur out of the diesel. And we still have some kind of low sulfur fuel oil. So the idea is, if you burn oil for a while in your oil burner, eventually it will rust because of the sulfur, and you will see some accumulation in your chamber. That is sulfur. Sulfur is not all bad. If you extract it, again, you can use it as a fertilizer, and it has a lot of good uses for us. But there's added cost of taking out the sulfur from the oil. Stable oil and fractured oil and storage issues. That's another important issue. That once This oil has been there sitting in the ground for millions of years. It's very stable. It did not change for millions of years, 100,000 of years. It was there, stored, and it's fine. When we fractured the oil and distilled it, then we took sulfur out of it, we added some additives, it became unstable. I'm not going to go to the chemistry into it, but it's unstable, which means it will unite more with oil, with water, or with oxygen. If it unites with oxygen and water, it will form different kind of chains and become different material. So you cannot store oil for a long time. It should not be in your tank more than one season. If you have a car that that you're storing for a while and not using, if the tank is full of oil, of gas, you have to change it. Even the engine oil you have to change once you get the car out of the storage, because what happens is there's some vapor in the air and there's some oxygen, and that will unite and react with the oil and form new material. So if you have diesel oil in a big tank, you've got a tank that's bigger than the house needs. You fill it once every 3 years. Is that a good practice? No, because whenever you displace oil from the tank, you're gonna replace it with air. You agree? Air has oxygen, has some water vapor, and has some humidity. The water vapor, after a while, it will condense and get into your tank. Diesel oil is organic, and if there's water and organic matter, bacteria will have something to thrive on. So bacteria will start eating your oil, and you'll have some kind of sludge at the end of the bottom of the tank. Same thing with your gasoline. After a while, it will gum. It will form some material that's kind of gummy, and it will clog your fuel pump and might ruin your engine. So, of course, there's a strainer. However, if you store the car for a long time, if you don't change the engine oil or the gasoline, it will have some gum, and it will start to react, and it's not going to be the same property. So, storage is always going to be an issue, and think about that when you size a tank for oil for a house, that it will be only for one season, and then every time it gets filled, somebody has to go and check the tank for water. There's always going to be some water in your tank, and there should be a drain for it. So we'll talk about that. So having water in the oil is not a good idea, because that will be a good environment for bacteria, and bacteria will eat your oil slowly. Did you ever see like rubber matter or plastic that start to mold and some bacteria start to feed on it? Mostly organic matter. Plastic is very strong, and it's hard to deteriorate, which is also an issue, because plastic becomes a permanent substance in the earth, and it's hard to break down. So stable oil and fractured oil. The new oil that we have now without the sulfur, it's sulfur processed. It's good for the environment, but it's not good for storage. You cannot store oil. So usually refined products, they don't have a lot of shelf life. Original product or pure product you can store for a long time. So American Society for Testing and Material, they do the standards for how long do you store oil, and what is the standard for all these oils. Does the oil meet the standards, and what standards are we talking about?
What if you stored the oil in like an airtight, like bag, just to do?
How are you gonna get it out? It's still going to decompose slowly. It will eventually decompose slowly. So low sulfur oil is that what we have, and that's the standard. And the heating oil is different than the car oil.
If you buy a new Volkswagen or Audi, you have to put low sulfur oil in it.
They all have low sulfur now. It's a necessity now. So low sulfur oil is very important, and they are the same properties. However, they are taxed differently. That's why they have different color. So the diesel oil you buy for your truck is the same one for your house, and the house diesel oil is cheaper because it's taxed differently because we need it. The trucks probably they pay more. So if you go and fill your truck, probably it's around like $4.50, but for a house probably it's $3 something. And the government subsidizes that because it's a necessity to heat the house. So let's write down those things and try to understand what they mean, because they're very important. And it's gonna come in your oil burn exam, and it's gonna come in many of my quizzes. What is the flash point? flash point is the maximum temperature at which the fuel can be safely stored and handled without a serious fire hazard. So flash point is a point that you do not want to exceed. Once you exceed that, we have a tank. You agree that when you heat something, you increase its ability to transform from liquid to gas, if you heat a liquid. So the flash point is the temperature where you want to store the oil below. It's the maximum, you don't want to exceed that. So we'll see what is the flash point for diesel. So at the flash point, this will start to evaporate. And what happens when things evaporate? Yeah, and it will it be easier or harder to ignite? Easier to ignite. So you want to store things below flash point. Gasoline has very low flash point. You can put a can of gasoline here and you smell it at the end of the glass. It's flashing. If you smell something, that means there's a molecule loose in the air. So that's the flash point. So oil you should not store oil above the flash point because it will start to evaporate and that will make it easier to ignite. It's really hard to ignite oil, fuel oil. That's why we prefer to use fuel oil rather than kerosene in your house. Because again, look at the distillation column. This goes by density. This is heavy. This is light. So as we go up, less density. However, they're all heavier than oil. So the flash point is the maximum amount of temperature, and the flash point is around 100 degrees Fahrenheit for diesel oil. And that's around, what's 100 Celsius? I'll say around 38 in Celsius. And that's the flash point will start to evaporate.
For which oil?
37.
Huh? For diesel, fuel oil.
Is that gonna be on the oil test?
Yeah.
The oil burn?
They'll ask you about the flash point. They want you to know. DO.
Wow, you were right on the money with that. 37.78.
Diesel oil. That's what we're gonna work on, is diesel oil. So, that kind of tells you, where should you store your oil? That's why you always store oil inside the house. In the summertime, you don't want it to start flashing and causing fire. So you put it in the shade, your house is not going to be more than 100 inside, hopefully. And usually it's in the basement, so it's very cool. If you store it outside, you have to provide some kind of shade. That has to be sealed and also has to be white color. We'll talk about that as well. So it's the point where the fuel is just beginning to vaporize, but there is no enough vapor to support flame. It's not enough concentration of vapor to support flame, so it should be below the point. Okay. For number 1 and number 2 fuel oil, 100 degrees is the flash point. Ignition point, the temperature where the fuel oil will start to burn for at least 5 seconds. It will start to ignite. And that's 637 degrees Fahrenheit. I get here 500 from the book. I'm gonna go with the book. I'm gonna change that. So, does he even have the book?
Yeah.
Who doesn't have the book?
Oh, I don't have one.
Yeah. Why not?
Where is it down to?
You can buy it in the bookstore and you can download the PDF from the Blackboard.
They don't have any more in the book.
Yeah, so
I
again,
bought mine directly from the manufacturer.
yeah, it's very cheap.
The shipping kills it.
$70.
Yeah, it's good, good reference, and you can have the PDF online. If you want, you can also, you can bring a computer or a tablet and start like taking notes because it's full of good information that you want to know. So this is the flash point is 500 Fahrenheit. So it will burn anything that within 500 it will start to burn. So at least 5 seconds. Pour point is the lowest point where the oil will start to flow. What does that mean? It means if you cool it below 20 degrees, it's not going to pour, it's going to be like honey, it's going to be very viscous. It's going to be very coagulant. So that's the pour point, the lowest point where the oil will start to flow, which is 20 degrees Fahrenheit. So what happens last 2 weeks if we have your oil outside or the basement is so cold?
It would freeze.
It's going to freeze, so you have to put some way to heat it up, heating pads or heating coil, otherwise it's not going to cool. So the pour point is about 20 degrees Fahrenheit. It varies by the temperature. And you need to know that. It's going to be part of your job to know what is the pour point and why this water is clogged. In a cold day when you need the heat the most, there's no heat coming into your house. That's the pour point. There are 3 ways to counteract cold weather. What would you think? If I have a tank that is outside or in the basement and it's so cold outside and I start to have oil. So first one is heat. You gotta keep it warm, otherwise it's not going to flow. Second, increase the pressure, meaning you're gonna get a stronger pump that can soften the oil and keep it under a lot of pressure. And third, use additive, mainly kerosene.
Is this at the point where it's at frozen?
Yeah.
So
So,
when it's at the pour, below the pour point, those are the 3 things you can do to.
yeah,
Okay.
yeah. If you live in Alaska and it's so cold, these are the 3 things you have to do. Probably it's a common practice over there. So, if you ever had a diesel car before the 90s, you have to keep that car in the garage and you have to have an engine heater, otherwise it's not going to start. Because it's so cold. And sometimes there's some additive you can add to it. Gasoline has a very high tolerance to cold, so it can be minus 16 outside and your car still start because it's lighter and has more resistance to freezing. What if you have to think, what can you substitute gasoline with?
You could use transmission oil in some cases.
It's very light, right? Transition oil is mostly what? Alcohol. If you go to the gas pump now, what does it say in the gas pump?
Octane, what is it, 5% ethanol?
Yeah, 10% ethanol now. What is ethanol?
Oh, well.
Alcohol. Alcohol. So eventually, with some tweaks in your engine, you can run your car on alcohol.
So you can pour Tito's down there and it'll work?
No, they need more than that. Probably you need like moonshine.
Like Mr.
Over 100 proof.
You know that the Model T was supposed to run on moonshine, right?
Good.
Yeah, that was the design. It was supposed to run on moonshine. So the idea is to push out more ethanol, but it's more expensive to produce moonshine than gasoline.
Are you talking about like that pure grain alcohol?
Yeah,
stuff?
yeah.
Oh, that's good.
Thing that you can light on fire. How much is a gallon of moonshine?
Depends, if you're buying it from like a guy you know, probably $100.
A gallon?
If you're just buying it from some dude, yeah.
That's
You
just
can't
so
buy in
you're gonna drink it,
Massachusetts
probably.
anything.
Oh
less
yeah, if
expensive.
you're buying it from somebody in the hills on a box.
You can only buy grain alcohol in Connecticut.
But
so
it's probably that's for drinking.
But in the
Yeah.
store, like $30.
$30 okay, or $3 for gasoline. So gasoline is still cheaper. So at some point now they're pushing for more abilities to have ethanol, which is renewable. If you have a Ford in the 2000s, it has something called flex fuel.
I have it.
Yeah, the flex fuel means that it can take more ethanol, up to 20% ethanol, which is again, now the government is trying to push for more renewable gas. So at least now we're doing 15% renewable, which is produced from unedible corn. They ferment the corn and make ethanol out of it. So that's the pour point for diesel oil. Cloud point, the point where the fuel oils start to crystal, between 10 and 20 above the pour point. So if the pour point is 20, so around 30 or 40, you look at the fuel oil and it's not clear. It's not clear cranberry juice color. It's stuck to cloud. looks kind of heavy, and that's called the cloud point. So you pour some and it looks kind of cloudy, it means it's a little bit cold. Viscosity. What is viscosity?
The thickness of the liquid.
Thickness and also the stickiness, how sticky it is. So would you say that honey is more viscous than the water? Yes. When you go and buy engine oil, and they tell you it's 1020, or 1030, or 550, what is that? It's the viscosity at 2 temperature. So, yeah,
Can you use the word cloud point? I don't, so 10 to 20, what, degrees above the pour point?
yeah, so if the
They'll
pour,
start to crystallize?
yeah, so if the pour point here is 20 degrees Fahrenheit. Above that is 30 to 40
Yeah.
degrees Fahrenheit. It will start to crystallize. It's
Almost
getting
like
heavy.
hardened?
Yeah,
Okay.
it's like heavier and heavier until you reach 20 and it's not flowing anymore. It's very sticky. So that's the pour point. And viscosity again changes with temperature. So when they give you 1020 oil, so that's 10 is when the oil is cold. It's gonna be the viscosity is very, it's a 10, which is like even more viscous, more heavy. When the car is warmed up and the car apparent temperature is around like 200 Fahrenheit, it will become lighter. So viscosity becomes lower as you heat the engine. So if we have, for example, 520 W something oil, that's the viscosity when hot. Viscosity when cold. So usually most cars 520, 1030, but if your car is burning oil, probably you can switch to heavier oil. And again, heavier oil will decrease your engine performance, but it will not burn oil as fast. Any questions about these?
Yeah, what's the W exactly stand for?
I don't know.
Nobody knows. I've heard like winter, I've heard weight, I've heard everything my whole career.
No, it's not weight. It has it's some kind of
Scientific.
code. No, it's some kind of code for them.
Okay.
Probably have code. They have W, they have N, they have S, C. Probably has its own notation. I'm not sure. Contamination. Water is our enemy because water will provide good food for what? Bacteria and fungus. And water is going to come into your tank at any point because you are siphoning some air to replace the oil that you're taking. So it will feed on water. And then you'll have sludge formation. Sludge is the byproduct of having bacteria. It's the bacteria waste. So bacteria will eat your oil and will produce some sludge. It's very slimy. And ASTM, they require the oil to be contaminated by maximum of 0.1% of contamination of the complete volume of oil. Density. The book is full of information. I'm trying to get you the stuff that actually we have to remember.
Would it be bad if you kept putting the wrong oil in your
Huh?
car? Like, does the oil in your car really make a huge difference?
In terms of performance, yes. The car will not perform as much. It's designed to perform at some kind of viscosity. It's not a big deal. If people always go with heavy oil if your car has long miles, a lot of miles, because the piston rings get like worn out, and there are small, tiny holes that oil can go through it and get burnt. So if you put heavy oil, the molecules of the oil is bigger, so it's not going to go through. So you can stop oil burning by putting heavier oil, but the car will decrease in performance. Probably you lose a lot of horsepower. So density 7.1 pounds per gallon. What is the density of water? 8, 8.1, 8.2. So again, it's lighter than
Now, is that
water.
for all oil? I thought you said somewhere.
Oh, yeah.
Is it
Heavier than
different
others.
for 6 versus?
This is for diesel oil.
So just diesel?
Yeah,
7.
yeah. So diesel 7 is going to be heavier, but even number 6 is going to be lighter than water. And this is number 6. I'm going to pass it. So it open. Okay, I'll pass it. Be careful. Oh, don't get this in your finger. Brings back memories. Don't tip it off. So 19,000 per BTU per point, and this is what we need to know: 139, 140, 137, depending on the quality of oil. But it's between. It's not always set. Depends on how heavy the oil, how was it refined. So it can change from one refinery to another. Color: cranberry juice color. And again, the cranberry juice color, it's a strong dye. And when you go to, if you use heating oil for your truck, the color will stain your car, and they will know that you used house oil. Yeah.
Yeah, that's what I was gonna ask. So, for
Yeah.
each BTU,
Yes, remember this one. This is some technical term you need to remember.
so just every gallon of diesel will give you 139,000.
Around.
You're
Yeah.
paying them $50 to drink a cup full of oil.
So the points are a measure of the quality of the oil.
Never again.
Points the measure of quality. It has some standards, but what you need to remember is it's 139 gallons per BTU per gallon. In very cold climate, you add up to 25 kerosene, 25% kerosene. So I'm gonna,
Yeah, I tried that once. My phone plug wasn't working. Tried to put a hose in my engine to try to suck it out.
up to 25% of kerosene. Make it pour faster. Tank problem. So tank, we're gonna spend the first chapter is talking about tanks and tank piping. It's very important, it's very problematic, especially if you go for oil companies. Oil companies they are trying to deliver oil. I want to show you something that's very interesting. I'll go over after I finish that. I'll explain some of the schematics here, just for information. So fast pumping is an issue. Why? You're gonna stir up a lot of the sludge and dust and rust in the tank, and you put it into your boiler. Rust is an issue. Water will encourage the growth of bacteria and will also rust your tank. And bacteria, of course, will eat your oil. How to deal with the problem? Every tank is a drain in the bottom, so you have to dispose of the tank and drain the sludge. And before you fill the tank, you should do some inspection, and if you can recommend the tank to be replaced or cleaned. It has to be professionally done by a technician. Everybody got that?
Hey Fahad,
Yeah.
quick question. So technically, if you just call your fuel oil company, they should fill your oil tank. And say you have like a power stroke diesel like pickup truck or something. You
Yeah.
just siphon it. Technically, it's the same.
It's very illegal.
So technically, they know how much oil you have and how much they fill. You have to have a contract with somebody. They will come to your house, do the inspection, which a few people do. They just fill in the tank, and they make a note of where is the fill pipe, and they will come and pump it into your tank. And when they pump the tank, they have to put two hoses, one for a vacuum, one for air, and one for oil. And we'll see some videos about that. It's very, very interesting. But yeah, to answer your questions, yeah, they do pump oil into your house.
Yeah, so technically you could take the oil out of your oil tank and put it in your diesel car.
Yeah, a lot of people do
and
that.
save like 40 cents a gallon.
Yeah, but the car will not pass the inspection, and you will get fined very heavily. Because the color will contaminate the entire car, and they will know.
Yeah, the smoke coming out of the muffler pipe.
Huh?
Right? The smoke coming out too, right? Of the
I
pipe?
don't know.
No?
Engine oil in the
Same
tank.
as diesel.
Yeah. You want to keep the tank clean. Avoid having water in your tank, and again, water will come from the air. So it's if you have a very humid basement, probably you're gonna have a lot of water condensation in your tank. Your tank is made out of metal. Metal is a good surface to condensate water. So whenever you bring some, if you take a gallon out of oil from your tank, you're gonna replace it with a gallon of air, correct? This gallon of air has few drops of water, it will condensate inside your tank. Buy from a good source.
What?
So the prices does vary, same as the gas station. At all gas stations have the same prices. It depends on the refinery, it depends on the structure, it depends on so many things I'm not really sure of. But buy from a good, reputable source, because they might, you don't know what kind of oil they will give you and what is their practices. Do they follow all the procedure? Do they follow all the safety procedures? And you will hear about some incidents where the oil people will come and fill different house and charge you for it. Yeah, I know this a few years ago with somebody, in the middle of the winter, they were confused and they filled somebody's basement with oil. Yeah, instead of a tank. The guy came, he saw the pipe, he just put in the fill tube in it and the whole basement was flooded.
That happened when my brother works.
Above 5
Lose
gallons
his
of
license, right?
contamination, that's an EPA issue,
Yeah.
5 gallons.
Lose your license
So
for
they're-
that.
He
they're
had
for
to
a
come
week.
into my basement and tear up all the concrete like 3 years ago.
Yeah,
My car exploded in our driveway,
Because someone
didn't do
filled
it.
my oil with
Yeah.
water.
Yeah, my car exploded, they took a gas pipe and exploded in my driveway, and the EPA had to come in and for like a year and run tests on the
yeah,
concrete.
that's good. Because this contamination
Yeah.
can be an issue. And if it was crude oil, it will be this for an issue. But now it's not crude oil. There's a lot of additive in it. It's very corrosive. It's very bad for the environment and it will seep out for a while. Most of the oil leaks happen over years and you wouldn't know about it. Like I worked in a pipeline. It was a really big cross-country pipeline, and it's really hard to detect a small leak. How would you know? And over time, you verify how much you shipped and how much you received. Over the course of 10 years, it was a small leak. 10 years that was not detected, because usually the density, the temperature shrink and expand the oil, so they thought it was just up to shrinkage. But then they found this actually was a small leak, small hole over 10 years, contaminated the whole area. How did they know? The plants started dying, animals started dying, and it was already deep in the ground.
How
So-
many gallons?
Huh?
How many
It
gallons?
was a lot.
How big was the?
Over 10 years. It was a small town. A small town was completely contaminated with oil. The people who used to live on farm there, they had to evacuate. And to take that oil out of to make it less contaminated will take 15 years.
I was gonna say, they're probably still doing it, right?
15 years, if they do it at all.
Somebody got
So
trouble.
this is why people were upset about the Keystone pipeline and the leaks. They're not doing it. It's really difficult to avoid contamination with small leaks here and there, or it's not even worth the money for them to fix it. If nobody's
They
complaining.
probably have like a number they can lose and don't care about, like the
Yeah.
profits.
But sometimes those small little numbers can get miscalculated. You don't know where it goes. And if you think of miles and miles of pipelines, you will lose something along the line and you contaminate the entire area. And it's not a good thing. So that's why the gas company comes to your house every once a year and check the gas for leaks, even though gas is not as contaminating as oil. And that's why we do not pump oil to houses. Because you know that 30% of the municipal water is lost due to leaks? 30%.
You pump heating oil to homes.
No,
In Massachusetts, you do?
no, not through pipelines to the city.
Oh, no.
Yeah.
Yeah, to the house.
You don't do pipe you do gas pipe all the way from to the city, but you don't pump oil, you don't pump liquid, because again, water is not contaminating, but again, you're losing a lot of water to leaks in the pipes. Filter, you always want
I don't
to
know how I feel about
put a
that.
filter. The filter looks like the car filter, and it's good practice to change the filter once in a while and look at it and see if there's some sludge. If there's some sludge and accumulation, you might recommend that the tank to be checked. And
Where are filters, like, where would?
usually it's outside the tank. So if you look at the shop, we have a filter, sometimes before the oil burner and sometimes right after the tank. It's easy change, same as the car filter. Take the compartment out, take it out, and put it in, put a new cartridge in it. So bypass the filter to stop the system. If you wanted to stop the flow through the filter, you bypass the filter so you can change it. So there's always a bypass. When you close the filter, there's always a bypass. So think about it. If the tank is full of oil and you try to change the filter, there's gonna be a lot of leaks. So you have to have two shut-off valves and a bypass with that time, change the filter, put it back again. So that's again another best practice that you have to put in the.
What do you mean by no stop the system?
I think that's to stop the system.
Oh, okay.
That's time. Let me fix it. So if you let me. Are you glad that you're done with this?
Well, that, those valves prevent airflow from getting in as long as you prime the filter, or you still have to bleed the pump after you do all that?
No, you don't have to bleed the pump. So you have a bypass here. This is your oil filter. You got a valve here. If you stop this valve and this valve too, the oil will go through inside, and you can change the filter. Probably gonna have some bubbles. Probably yeah, you will have to bleed the pump because if you put a new filter, it will have some bubbles. So you'll go to the oil burner here, and you bleed the.
Not as bad. They should do that on diesel motors, that doesn't even,
Yeah.
some of those, I mean, it takes a long time to get the air out of
Yeah.
the line in the diesel.
So it's good that you have a vent in the pump and you can bleed things out. And the other thing is for oil, like when you change your car oil, the only way you can get the filter is when you drain the entire oil. So for here, you cannot do that. It's not possible. So you need always to have a bypass, or at least thing to stop the system. If you see sludge in the tank, you should have when you take the filter. If you see some sludge, which is some kind of gooey stuff, you know the tank has a lot of bacteria in it, and you have to recommend the tank to be clean. Always use new gasket. So the filter comes with a gasket on it, and a lot of gaskets, once you press them once, they lose the elasticity. So you want to have a new gasket to keep the thing in place. You can use grease, or you can use oil. Sometimes they don't stick well. And make sure that the oil, once you put it in, there's no dew on it. I mean, it's not leaking even small amounts. Change annually and check before each season. A lot of people neglect that, not a good idea. Check with the manufacturer specification. What is the filter that's supposed to go through that tank? So make sure it's the same. And they're kind of universal. They don't change a lot, but some of them have their own filters. Yeah.
Would it be labeled on like the housing for the filter or not?
Sometimes it is, sometimes it's not. Again, new system usually are easy to work with, but old system probably you can even see the marking. And probably the filter has not been changed for like 10, 5 years. And you will be surprised how much things get like bypassed and people just do not care. If it's working, they really don't care about those sort of things. But that's going to be your job. And that's why you want to buy from a reputable company. They will charge you more, but they will add this to the bill. I'm going to change your filter, I will do this and that, inspect the tank. It takes time before you start pumping. So you tight the filter with 270 degrees, which is 3/4 of a turn. Don't over tighten because you might strip the thread. And now I want to go into the book and show you some stuff. You get that?
What was that, 320 degrees?
370. The book has very, very interesting information. I want to just skim through it. So chapter 1 was about the components of an oil burner, which is something I think we covered last semester and we went very close to it. And again, you gotta think of Nora is an oil company, so the book is a little bit biased towards oil and gas. So you'll see a lot of advertisements for oil. I don't want to blast because it's a big business. But again, if you have a choice between oil and gas, I'll choose gas for better burning. But oil is still very big. Viscosity changing with temperature, goes up and down. Here, what is that? What am I looking at? So here's the oil property that you'll see. Again, it's approximation. It's not 139. It varies between 135 to 140. Definitions for ignition point, pour point, cloud point, viscosity. Water problems, condensation, the gauge can let some air in, loose fill. You can get also water from the tank, from the filling tank, the filler truck. It has some water in it and you don't know about it. Major facts about fuel degradation. Heat can slowly cook your oil and decompose its properties. Sulfur, we're talking about sulfur, corrosion. Gel, what does gel come from? No? Bacteria. Sludge and gel is the same thing as bacteria from the sulfur. Incompatible fuel, if you add something that's not approved, sludge. The pour point here. Filter change. Different cartridge. This is very interesting. This tells you how big is the molecule of the oil. And remember when we looked at the 5W, 510W, it's all different kind of size of molecules. So some molecules are bigger than other. And I don't know why this information is here, but it is interesting. Bioheat. So biofuel is does anybody hear about No9 oil? So bioheat or bio oil is basically oil that we generate from plants, and we try to mix it with diesel oil. It has a little bit lower heating value, and when they talk about biofuel, it's not completely organic, it's not completely renewable. We mix that with the diesel oil. So I think No9 have biofuel. There's a lot of biofuel companies in Connecticut. It's a good step, but it's not completely renewable.
Was it just cleaner?
It's blend, so it's kind of like gasoline. We're using 15% ethanol, now we're using more biofuel. So it's bioheat, it's at least better, because we're saving more money, we're saving more of the fossil fuel and we're using the renewable fuel.
People using human waste for fuels too?
Huh?
Human waste for fuels as well?
I'm not sure about that. That's not a South Park thing, but.
Talk about methane or something like that. In the gas.
You could do that, I guess. Okay, so that's what I have for you for today. Let me go with a quick chair, make sure.